All right, so what I want to do now is take what we just learned about limits at infinity and apply them to trigonometric functions, okay? So let's say we see the limit as x approaches infinity of sine of x. Well, what does sine of x do as the values get larger and larger and larger? Remember that sine of x does this. It just goes up and down between 1 and -1, right? And it goes out to infinity. So if it just keeps changing, that means it's never settling in on a single value. It's never becoming an asymptote. It's also not going, way up to positive infinity or way down to negative infinity. It just keeps jumping between 1 and -1. And because it's not getting closer and closer to a single value, the limit of sine of x as x approaches infinity, there is no limit. Now remember that cosine basically does the exact same thing. It just oscillates between 1 and -1, right? And because it oscillates between -1 and 1, doing the limit of cosine as x approaches infinity is also no limit. It's, by the way, the same thing even if you do the limit as x approaches negative infinity. So for both sine and cosine, the answer is no limit as you approach infinity or negative infinity. I also want to remind you that the other 4 trigonometric functions, so let's say that you were to do the limit of tangent of x as x approaches infinity or negative infinity. In fact, we'll put a plus or minus here. Cotangent of x, cosecant of x, secant of x. All of them have this repetitive cycle of different shapes that eventually, go to negative infinity, then positive infinity, then negative infinity, then positive infinity, and they never actually get close to any one number, and they never even stay at positive or negative infinity. They just keep oscillating and cycling among all these numbers. Therefore, the limit at positive infinity or negative infinity of any one of these trigonometric functions is also no limit. So really, anytime you do the limit of a trigonometric function, if it's just a trigonometric function, as x approaches infinity or negative infinity, the answer is always going to be no limit. But that's not to say that every limit at infinity that includes a trig function is automatically no limit. I'm going to show you a couple examples right now. All right, now let me warn you that this is not the same problem that you saw yesterday, okay? This is not the limit as x approaches 0 of sine of x over x. This is the limit as x approaches infinity of sine of x over x, okay? And so the answer to this is not 1, okay? Actually, the answer to this is 0. I want to remind you, remember how I said that when you do a limit at infinity, you want to compare the relative strength of the numerator to the relative strength of the denominator, okay? Here, isn't this numerator basically always going to be somewhere between 1 and -1? Because sine of x oscillates between 1, -1, 1, -1, 1, -1. The numerator is not growing infinitely, okay? But look at the denominator. The denominator is growing infinitely. If you were to put like a million in here, you'd have something between 1 and -1 over a million, okay? Then you'd have 1 over -1 or -1 over a billion, right? And what ultimately is going to happen is because the denominator is growing without bound and the numerator is restricted between 1 and -1, this is going to be the same thing as dealing with the situation where, let's say you have x, x plus 1 over x squared minus 5. The power of the denominator is stronger, and when the power of the denominator is stronger, remember that our answer is always 0. So anytime that you have a trigonometric function in the numerator, and you do not have a trigonometric function in the denominator, then it will pretty much almost always, your answer will be 0. Okay? And it'd be the same thing if it was cosine. If you had cosine of x in the numerator, going to infinity, remember, cosine goes between 1 and -1, right? But the denominator is growing without bound. Therefore, the denominator is more powerful than the numerator, and therefore this limit at infinity is 0, okay? But what would happen if we flipped it over? What if instead we had x over sine of x? What if we had the limit as x approaches infinity of x over sine of x? Well, now the denominator is weaker than the numerator. The numerator is stronger, the denominator is weaker, and therefore when the numerator is stronger and the denominator is weaker, that's the same thing as having 7x squared over 3x minus 5, right? The power of the numerator is stronger, and then we say no limit or does not exist, right? One of the two of those, okay? And so that's pretty much it for limits at infinity involving trigonometric functions.